Right, now we get to the actual source code or programming of this. I'm using Energia or Energia. I'm not quite sure how you pronounce that, but I've got a sketch here called Fish Feeder. I've given a little bit of explanation of what's going on here. What we intend to do is on startup, delay for 2 seconds with the red LED on the launchpad lit, which will indicate that it is stopped or paused. So red is for stop and green is for go. And if you press the push button 2 during those 2 seconds, we'll enter debug mode. In debug mode, the frequency is set to every 15 seconds. Debug feed frequency, actually it's every 2 seconds. So let's just correct that right now. You can change this in debug feed frequency milliseconds, which is this here. So that's the frequency in milliseconds. That's 2 seconds of how frequently we will feed the fish. So the program uses the MSP 430 clock to delay 24 hours between feedings. That's normal, 24 hours. That's 24, 60,000 milliseconds. So change this in the frequency MS if you want. So if you want to feed your fish twice a day, you would obviously halve this value here. It's not set up to feed at a particular time of day. It's set up to feed on a regular schedule. So you need to start the program at the time when you want to feed. It does keep a feed count, which we're not actually using at the moment, but there are plans in my mind at least on showing the number of feedings on a little display. So the motor I'm using is again the 28BYJ 48 stepper motor, and it's turned 10 degrees for each feeding. Now, I'm not quite sure what that is. I haven't actually made the wheel at this point yet, but I'm going to. So it may change from 10 degrees, but that's just what I've gone with. We set up a couple of constants. The start delay, which is the 2 seconds, to allow you to press the button. So if you wanted to change that 2 second delay at the start of the program, you could. Then we have the actual start time, which you'll see being used later on, and the next feed time, which again you'll see later on. Now these two are going to be using the built-in millis, which is millisecond function, which gives you the number of milliseconds that the program has been running on the MSP 430. And that is limited by 50 days, or approximately 50 days, because 50 days in terms of milliseconds causes an unsigned long to overflow, which means it'll return to 0 again. But for the next feed time, we set that to 0, meaning we should have already fed the fish by the time this thing runs, because that's 0 milliseconds from start. Now, I set up some pins. Remember I said I'm using pin 2.2, 2.1, 2.0, and 1.5, or pin 1.5 on the MSP 430 because they are the bottom 4 most pins on the left-hand side of the chip or launch pad. It makes it easy for me to connect the motor. I then make an array of those pins because I'm going to loop through the pins, setting one high after the other. So I've got a pin count of 4 just to say how many there are, just saves time. And currently we're using pin 0, which is, pin 1, which is 1.5. We're at position 0 in that array. Now, during the setup of the program, we'll set the pin modes. That's something we have to always do, to say these are output. And as I said, on the push button, I'm using input pull-up. That's because resistor 34 is missing on my launchpad. If you have a resistor on in that position on your launchpad, you probably don't need to say pull up, you can just say input. Set all motor pins as output. So the 4 pins that we're using, that's the pins, I should have really maybe called these motor pins or something, but that collection of pins, which is pin 1 through pin 4, so these pins here are all going to be set to output. And at the same time, once I set output, I say write low, which means effectively don't put any power out on that pin. Then I switch on the red LED. So we've set up the pins. That's the first thing we do. Then I write out, switch off the green and switch on the red LED to indicate that we've stopped. This is just in serial output, and Energia has an option to monitor your serial port, and that'll show you messages that you're writing out from your program when it's connected through USB. giving the user a chance to press the button. So what I'm saying here is while the millis, that's the number of milliseconds since we started, is less than the delay, which remember up here we set to 2000. Whoop, we're set to 2000. So while that's less than 2000, if I read that push button has been pressed, then I'll enter debug mode and I'll break out of this loop and we'll start the program straight away. Now, enter debug mode, I'll just jump to that straight away. Oops, is this whole method here. Something just to give me some feedback, let us know what's going on. Give some visual feedback. Let's flash the red and green LEDs a couple of times. And we change the feed frequency to super fast feeding mode. So debug frequency, which we set up here, debug feed frequency is every 2 seconds. So it would be 24 hours, but if you press the button, if you press that button during the delay, the 2-second delay, then we're going to change the feeding cycle to every 2 seconds. So it'll set it to 2 seconds and says feeding frequency is now, and it tells you how many milliseconds. Once that's over, either you've pressed the button or you've let the 2 seconds elapse. We're green for go. So we switch the LED high, so we switch on the green LED and we switch off the red LED. And we write out on the serial that the fish feeder is active. We set the start time as the milliseconds and the next feed time as the start time. So the next feed time is now. What Energia has is it has the setup routine, which we've just been through. And once setup is complete, it will run the loop function continuously, or until reset is pushed on the thing, or until power is removed. So in the loop, we feed the fish. I'll come back to that in a moment. And there's nothing to do until the next feed time. So what we're going to do is delay for as long as it takes until the next feed time. So we determine how long we need to sleep by subtracting how long we've been running from the next feed time. And then just for debugging purposes, we output on the thing to say how long we sleep. We then delay for that number of milliseconds. So our program is halted at this point, which means it's actually using very little power. We're not doing anything until we get to feed the fish again. So on a 24-hour cycle, for most of those 24 hours, you'll find that this is what's happening. It is just sleeping. So let's look at feed the fish. Here's feed the fish. First we'll do is switch the green LED on and we switch the red LED off. This indicates that we are not paused at the moment or not stopped. We are actually trying to feed the fish. We increment the number of times we've fed the fish, so the feed count gets incremented, and we write out on the serial output, in case somebody's monitoring this, that we're feeding the fish, and we tell it how many times we think we've fed the fish. Now this is all to turn the motor. Before I was turning the motor, I had a simple delay in here to indicate that something was happening. So what we do is we determine how many steps the motor needs to take for each feeding hole. That, in other words, when we're turning the motor, how much do we need to turn that motor, or how many steps do we need to make? And for each step, we then iterate through the pins. So here you see digital write, the current pin, whichever the current pin is. Now remember, up here at the start, we made current pin number 0, which meant this one here. So pin 1.5 will go high. Let me get back down to the program. Pin 1.5, is set to low, so they're all low. We increment the pin. If the current pin is more than the pin count, then we return to the first pin. So we'll go 0, 1, 2, 3, and then we're more than 4, so we go back to 0. And then we digital write that current pin on high, and we delay for 2 milliseconds. Now the reason we need to delay for 2 milliseconds is because the motor controller can't actually go as fast as our MSP 430. If we don't delay here, the motor won't turn. So we need to have a slight delay between each step of providing power to a pin. So that loop will happen for a certain number of steps, so to speak. We don't quite know exactly how many, and for that reason I've written a program to analyze the number of steps required. The next feed time is incremented by the feed frequency in milliseconds. Now we know that the feed frequency, well, in debug mode is 2 seconds, so we'll increment the next feed time by 2 seconds. And then we obviously switch the LEDs again to say we're not green anymore, now we're red because we are paused, we are not feeding the fish at this point. And because the next feed time has been incremented, we can subtract the number of milliseconds here. The reason I'm doing this rather than simply having a set sleep time is because feeding the fish could take a variable amount of time. So if feeding the fish took, let's be ridiculous here and say if it took 5 minutes to feed the fish, we don't want that 5 minutes to increase over each 24-hour period. So the sleep time here wouldn't be 24 hours. It would be 24 hours minus the time it took to feed the fish. And the result of that is that the fish get fed exactly 24 hours after the last feeding began. So just wrap that up again. We have a number of variables and constants set up here for controlling the motor, for the frequency, and for the actual program. We set up the pins. We do some debug output. We wait for 2 seconds for the user to press push 2 button. If they do, we enter debug mode, which means, in a nutshell, we will feed every 2 seconds. And then we say we're good to go. And good to go means run the loop program. So it'll then run the loop which feeds the fish. All the feed the fish does is red is off, green is on, turn the motor a certain number of steps, and then switch back to a red LED to indicate that we're stopped, and then we sleep. So it's fairly straightforward.